we're going to be cracking open the world of artificial intelligence.
Oh, very exciting.
And not the Hollywood version with robots taking over,
Right.
but the real AI that's already changing, how we live and work.
Yeah, it's everywhere.
Yeah, and we are working from a great starting point.
Okay.
This excerpt from Melanie Mitchell's book, Artificial Intelligence, A Guide for Thinking Humans.
Yes. It's a great book, and it's really crucial to understand this topic these days.
It is, and I was a little worried when you sent me the source material that it was going to be some dry technical manual.
Yeah.
But it's not.
Yeah.
Mitchell actually takes us through her own journey into AI, starting with this book that she read that really blew her mind.
Oh, wow.
Douglas Hofstadter's Gödel, Escher, Bach. Have you ever heard of that one?
Oh, absolutely. It's a classic.
Yeah.
And, it's really interesting how Hofstadter's early anxieties about AI, especially like music composition programs.
Oh, interesting.
Really foreshadow a lot of the themes that we're going to explore today.
Yeah.
He was worried that these programs were like encroaching on something uniquely human.
Really?
Which is a big question.
Yeah, so let's rewind to the very beginning of AI.
Yeah.
We're talking like the 1950s,
Oh.
the era of like punch cards and room-sized computers.
Yeah.
Specifically, the Dartmouth Summer Research Project on Artificial Intelligence in 1956.
Oh, yes.
And these computers were millions of times slower than our smartphones.
It's mind-boggling.
Can you believe it?
I know, and they thought they could build a fully intelligent machine in a decade.
Oh, wow.
Talk about ambitious.
Really makes you appreciate how far we've come.
Yeah.
But also how those early expectations kind of set the stage for the AI landscape that we see today.
Yeah, because then we went through cycles of AI springs and AI winters.
Oh, right.
Periods of crazy hype and big promises, followed by, disillusionment and funding cuts.
Yeah.
So it's kind of been this roller coaster ride.
And, speaking of understanding, one thing that surprised me
Okay.
was that even now there's no single universally accepted definition of AI.
That's interesting because maybe a rigid definition would actually be a bad thing for the field.
Oh, how so?
Well, it allows the field to be flexible and adapt, quickly as new ideas and technologies emerge.
I see.
It's constantly changing.
So how do we even start to categorize the different ways people have tried to build AI?
Yeah.
Mitchell breaks it down into two main approaches, symbolic AI and subsymbolic AI.
Okay, good place to start.
Yeah.
So symbolic AI, think of it as giving the computer a really detailed set of instructions.
Okay.
Like a rule book for intelligence.
Okay.
So you define every step, every rule, every possible scenario.
It's like teaching a computer to think by giving it a super complex flowchart.
Exactly.
Right.
And a classic example of this is the missionaries and cannibals problem.
I've heard of that one.
Yeah, so you've got 3 missionaries and 3 cannibals.
Right.
And they need to cross a river in a boat that only holds 2 people. And the trick is you can never have more cannibals than missionaries on either side of the river or, bad things happen.
Right.
Right?
Cannibals gonna be cannibals.
Exactly. So symbolic AI solves this by creating all these rules. Like,
Wow.
if cannibals outnumber missionaries, then move 1 missionary back.
So it's like a logic puzzle where the computer's crunching through all the possible moves
Yeah.
based on these predefined rules.
Right. And that was the dominant approach in the early days of AI, especially with these expert systems.
Oh, expert systems.
Yeah.
Now those are
So imagine like doctors inputting a patient's symptoms.
right.
And then the AI uses a massive set of rules from medical textbooks to kind of help diagnose.
Wow.
And, it's not as trendy as some of the newer approaches.
Right.
But symbolic AI is still relevant today, especially for tasks that require logic,
Right.
reasoning, and common sense.
That makes sense.
Yeah.
But what about this other approach, this subsymbolic AI?
Okay.
That sounds a lot more mysterious.
It's inspired by the human brain, particularly thought processes that happen below our conscious awareness.
Okay.
So things like recognizing faces,
Yeah.
understanding language,
Uh-huh.
or reacting instinctively to a sudden movement.
So instead of giving the computer explicit rules,
Yeah.
we're trying to build systems that learn and adapt kind of more like our brains do.
Exactly. And that's where neural networks come in.
Neural networks.
Yeah, okay. And the earliest type, the perceptron, was actually modeled after how a single neuron in the brain works.
Oh, wow.
So imagine it takes in different inputs, each with a certain weight or importance,
Okay.
adds them up, and then decides whether to fire or send a signal based on a threshold.
Okay, I'm following you so far.
Okay.
But how do these artificial neurons actually learn?
Good question.
That's the part that blows my mind.
It's all about training.
Okay,
So let's say you want to teach a perceptron to recognize the handwritten digit 8.
okay.
You show it tons of examples of 8s, along with other digits telling it which ones are correct.
Mm-hmm.
And the perceptron adjusts its weights and that threshold based on its successes and failures.
Mm-hmm.
And over time, it gets better and better at recognizing 8s,
Wow.
even ones it's never seen before.
That's wild.
Yeah.
So are these neural networks like the secret sauce behind all the amazing AI that we're seeing today?
They're a big part of it, especially the more complex networks that we'll talk about later.
Yeah.
But it's important to remember that the journey of AI hasn't always been smooth sailing.
Yeah.
There were times when neural networks fell out of favor.
Oh, right. What about that whole thing with Marvin Minsky?
Yeah.
Didn't he throw some shade on perceptrons?
He did. He was a giant in the field. And his book, Perceptrons, which he co-wrote with Seymour Papert,
Okay.
pointed out some serious limitations of those early single-layer networks.
Okay.
And while they acknowledged the potential of more complex multi-layer networks, they thought research in that area would just be like a dead end. When, sadly, that skepticism contributed to what's known as the AI winter.
The AI winter. Now, wasn't that when funding for AI research dried up
Exactly.
and progress just stalled?
Yeah, it was a dark time for AI.
And it kind of highlights a crucial distinction, right?
Yeah.
The difference between narrow AI and general AI.
Right.
Narrow AI is what we're mostly seeing today, systems that excel at very specific tasks.
Right. Playing chess or recognizing faces.
But general AI,
Yeah.
that's like the holy grail, right?
That is the holy grail, a system with human-level intelligence that can learn and solve any problem.
Uh-huh.
And that's still a long way off.
Okay, so we've got this roller coaster of expectations, these different approaches to building AI and this elusive quest for general intelligence.
Right.
But this all leads to some pretty profound questions, doesn't it?
Yeah.
Like, can we really create machines that think?
Right.
And what does that even mean?
We're getting into philosophical territory now.
Yeah.
And those are questions that have been debated for decades.
I'm thinking about Alan Turing and his famous imitation game,
Yes.
now known as the Turing test.
Right. If a machine can converse so well that you can't tell that it's not human,
Yeah.
shouldn't we consider it to be thinking?
That's a thought-provoking idea.
Yeah.
But then there's John Searle's Chinese room thought experiment.
Okay.
So imagine someone inside a room with a rule book for manipulating Chinese symbols.
Okay.
They can respond to questions in Chinese without actually understanding the language.
Oh, so are we just creating these clever mimics? Or are we on the verge of something truly groundbreaking?
That is the question.
It's a debate that's still going strong today,
Yeah,
especially with all these new AI systems that seem so eerily human-like.
absolutely.
Yeah,
It's enough to make your head spin.
yeah. But before we dive too far down that rabbit hole, let's switch gears and talk about the technology that's really driving this current AI boom.
Okay.
Deep learning
Yes.
and the power of big data.
Let's do it.
Now we're talking.
This is where it gets really
This
interesting.
is where it gets really
Yeah.
interesting. Okay.
Okay, so deep learning, it's almost like a magic spell, the way
Mm.
people talk about it.
Mm-hmm.
What is it about deep learning that's made such a huge impact, especially in the last, decade or so?
Well, imagine those neural networks that we talked about earlier, but now stack them up in layers.
Okay.
So you're creating these incredibly complex structures with millions, sometimes billions of artificial neurons.
Wow.
That's deep learning in a nutshell.
Okay.
And what's fueling these deep learning behemoths is this explosion of data that we have now.
Right. I mean, we're generating more data than ever before.
Absolutely. It's like giving these deep learning models a massive feast of information to learn from.
Right.
And they are hungry learners.
Yeah.
One specific type of deep neural network called convolutional neural networks, or ConvNets for short,
Yeah.
is the real star when we talk about computer vision.
Confidence. Okay, so those are the brains behind things like facial recognition on our phones, self-driving cars.
Exactly. They are incredibly good at analyzing images, but what really propelled them forward was a game changer called ImageNet.
ImageNet. What is that?
Think of it as a gigantic visual encyclopedia created specifically for AI.
Oh, wow.
It contains millions of images, each meticulously labeled by humans.
Wow.
Pictures of dogs, cats, cars, trees, you name it all, organized and categorized.
So it's like teaching AI to see by showing it millions of examples.
Exactly. And the creation of ImageNet itself was a monumental effort.
Yeah.
They use Amazon's Mechanical Turk platform to get thousands of people to help label all these images.
That's amazing.
Talk about a human-powered AI project.
So how did ImageNet lead to this breakthrough in computer vision?
Well, they held these annual competitions
Okay.
where researchers from around the world would pit their AI systems against each other
Oh, cool.
to see which one could most accurately classify images from ImageNet.
Okay.
And in 2012, a team from the University of Toronto shocked everyone with a conmet called AlexNet.
AlexNet. What was so special about AlexNet?
It blew the competition out of the water, achieving an accuracy that was unheard of at the time.
Oh.
It was a real watershed moment, proving the power of deep learning in computer vision,
Yeah.
and it sparked a wave of innovation.
Okay, but hold on. I've heard that even these super smart connets can be fooled. Something about adversarial examples.
Yes, the Achilles heel of AI vision.
Okay.
So adversarial examples are these images that have been subtly manipulated,
Okay.
often in ways that are invisible to the human eye,
Yeah.
to cause a convent to misclassify them.
So you can take a picture of a school bus,
Yeah,
change a few pixels here and there, and suddenly the AI thinks it's an ostrich.
exactly. It's like giving the AI an optical illusion that it just can't see through.
Oh, wow.
And it highlights a crucial difference between AI vision and human vision.
Okay.
You know, ConNets are great at recognizing patterns,
Yeah.
but they don't understand the world the way we do.
Uh-huh.
They lack that common sense and context that allows us to see through these tricks.
Okay, so AI might be making strides in vision, but what about something even more human, like language?
Yeah.
How is AI doing when it comes to understanding and generating text?
That's where natural language processing, or NLP, comes in.
NLP.
And it's a field that's seen incredible progress thanks to deep learning.
Yeah, I mean, we use NLP every day without even realizing it, right? Serial X, the Google Translate, they're all powered by NLP.
Absolutely. And the advancements have been remarkable.
Yeah.
Think about speech recognition.
Yeah.
Just a few years ago, those systems were so clunky and error-prone.
Yeah.
Now they can transcribe our ramblings with surprising accuracy, even with all of our ums and ahs.
It's almost creepy how good they've gotten.
I know, it's pretty amazing.
But do they really understand what we're saying?
Yeah,
Or are they just really good at pattern matching?
that's the million-dollar question.
Yeah.
They're definitely getting better at understanding the nuances of language,
Uh-huh.
but they still lack that deep human-level comprehension.
Yeah.
And it's not just about transcribing words. It's about deciphering their meaning, their emotional weight.
You're talking about sentiment analysis, right?
That's
Like
right.
figuring out if that online review is positive or negative, or if that tweet is sarcastic.
Exactly. It's a huge challenge for AI because language is so nuanced.
Right.
You can't just look for keywords like good or bad.
Yeah.
You have to consider the context, the tone, the cultural references.
Right.
Irony and sarcasm can trip up even the most sophisticated AI systems.
It's like those movie reviews that Mitchell mentions.
Yeah.
One person might say a film is devoid of charm or wit.
Right.
Well, another describes a scene as simply fantastic, but then storms out of the restaurant without paying.
Right.
Both are expressing negative sentiment,
Yeah.
but in very different ways.
Exactly. It highlights the challenges of teaching AI to read between the lines,
Yeah.
to understand the subtleties of human communication.
Right.
But despite those hurdles, there have been some really exciting breakthroughs in NLP.
Okay.
And one of the most intriguing is this concept of word vectors.
Word vectors. I'm intrigued. Tell me more.
Think of it this way. Instead of treating words as these isolated units, we can represent them mathematically in a way that captures their meaning
Okay.
and their relationships to other words.
So it's like creating a map of language where words with similar meanings are kind of clustered together.
Precisely. And these word vectors are created using a neural network called Word2Vec.
Okay.
It's trained on massive text data sets, learning to predict which words tend to occur near each other.
So by analyzing how we use language, the AI is learning these subtle connections between words. That's incredible.
It is. And what's even more amazing is that these word vectors can capture analogies.
Wow.
For example, the relationship between man and woman is mathematically similar to the relationship between king and queen.
Whoa. So we're teaching AI to understand metaphors. It's mind-blowing.
It's a glimpse into the potential of AI to grasp the deeper structures of language.
Yeah.
And these word vectors have been revolutionary for machine translation.
Google Translate.
Yeah,
It's gone from being a source of amusement
right.
to being surprisingly accurate in many cases.
Yeah, it really has come a long way.
How did word vectors help with that?
Well, the latest machine translation systems use this clever combination of encoder and decoder networks.
Oh.
The encoder network reads the source sentence and creates a vector representation of its meaning. Then the decoder network takes that vector and generates the sentence in the target language.
So it's like the encoder is distilling the essence of the sentence, and the decoder is reconstructing it in a different language.
Exactly.
All thanks to these word vectors.
All thanks to word vectors, a huge leap forward from those early systems
Yeah.
that would spit out these jumbled, often hilarious translations.
Right.
You know, those are good for a laugh.
But even with all this progress, machine translation still has its limits.
Of course.
There
It
are.
can stumble over idioms, cultural references, humor,
Yeah.
those things that require deep understanding of the nuances of language and human experience.
It's a good reminder that fluency in a language goes beyond just knowing the vocabulary and grammar.
Right.
It's about understanding the culture, the context,
Yeah.
the unspoken assumptions.
Exactly. But the advancements in machine translation are undeniable. It's making communication across language barriers easier than ever before.
And it's not just translating text. AI is now tackling this amazing task of image captioning,
Yes.
generating descriptions for images based on their pixel content.
Another example of how AI is bridging the gap between different forms of information.
Yeah?
Google's show and tell system is a great example. It was trained on millions of image caption pairs, learning to recognize objects, their relationships, and even the overall scene
Wow.
to generate surprisingly accurate descriptions.
So it's not just saying, this is a dog.
Right.
It's saying, this is a golden retriever puppy playing fetch in the park.
That's right. It requires a level of understanding that goes beyond simple object recognition.
Yeah.
It's about making sense of the visual narrative, the story unfolding within the image.
It's incredible how AI is kind of weaving together these different threads of information from pixels to words and back again.
It is. It's opening up a whole new world of possibilities, blurring the lines between vision and language.
So what about the next frontier? Can we move beyond these simple voice commands and create an AI that truly understands our questions and gives us, like, insightful answers?
That's the holy grail.
Yeah.
And it's a challenge that has captivated AI researchers for decades. If there's one system that's captured the public's imagination in this quest, it's IBM's Watson.
Ah, yes, the AI that went head-to-head with Jeopardy! Champions.
Yes.
And emerged victorious.
Emerged victorious.
It was a thrilling spectacle, and for a moment, it felt like we were witnessing a true AI breakthrough.
It was an incredible feat, no doubt.
Yeah.
Watson, armed with deep learning and a massive knowledge base,
Yeah.
could answer complex questions posed in natural language,
Right.
often surpassing its human competitors.
Well, Watson wasn't perfect, was it?
Yeah.
I remember reading about some of its unhuman-like errors.
Well, like any AI, it wasn't infallible.
Yeah.
And what was so fascinating was that Watson's mistakes weren't always predictable.
Oh, really?
Sometimes they were downright bizarre,
Wow.
revealing the limits of its understanding.
I remember one clue about a U.S. gymnast
Yeah.
with an anatomical oddity who won a gold medal on the parallel bars.
Oh, yeah.
And Watson guessed leg when the answer was missing arm.
Oh, wow.
It was a stark reminder that while Watson could process information at lightning speed,
Right.
it didn't always grasp the nuances of human experience.
Yeah, it didn't have that lived experience that we have.
Yeah.
That informs our understanding.
So it sparked a debate, right? Was Watson a genuine breakthrough or just a clever trick?
It's a question that lingers, especially as Watson's real-world applications have faced challenges.
Yeah, it kind of highlights this ongoing struggle
Yeah.
to bridge the gap between AI's impressive performance in these controlled environments
Right.
and the messy complexity of real-world applications.
Exactly. And it underscores a fundamental limitation that continues to plague even the most sophisticated AI systems.
Uh-huh.
The lack of common sense.
Common sense.
Yeah.
It's like that vast unspoken knowledge that we humans take for granted.
Yes.
You know, knowing that a cup of coffee is hot without having to be explicitly told.
Right.
Understanding that if someone is running towards you with a panicked look, it's probably a good idea to get out of the way.
Exactly. It's
Uh-huh.
that kind of knowledge that allows us to navigate the world intuitively,
Right.
to make inferences understand the why behind the what.
And teaching AI common sense has proven to be a really formidable challenge, hasn't it?
It has. Early attempts like the Psych project tried to manually encode common sense
Yeah.
into this massive database of rules.
Oh, well.
It was like creating a digital encyclopedia of everything we know about the world,
Yeah.
but it turned out to be incredibly complex
Right.
and ultimately a very limited approach.
Yeah, it makes you realize how much of our understanding is rooted in our physical experience, our embodied interactions with the world.
Exactly. AI systems, at least for now, lack that grounding.
Yeah.
And without it, they struggle with tasks that seem effortless to us, like predicting how objects will behave,
Right.
understanding social cues,
Uh,
grasping the essence of a situation.
Mitchell uses the example of intuitive physics.
Oh, yeah.
Imagine a dog on a leash sniffing the ground as its owner tries to cross the street.
Yeah.
We as humans can instantly predict all sorts of possible outcomes.
Right.
The dog might resist, the owner might pull, the dog might step out into the street.
Right. All kinds of possibilities.
But AI systems, without that intuitive grasp of physics and behavior, would really struggle to anticipate those possibilities.
Yeah, they would struggle to anticipate the unexpected.
So it's a reminder that common sense isn't just about knowing facts.
Right.
It's about understanding how those facts connect, how they play out in the real world.
Exactly. And it's a key ingredient that seems to be missing from even the most advanced AI systems.
So if AI is struggling with common sense,
Yeah.
how is it faring with something perhaps even more profound? Abstraction and analogy.
Those are really good points, and those seem like such hallmarks of human intelligence. You're right, and those are precisely the abilities that AI researchers have been grappling with for decades.
Yeah.
Mitchell introduces these Bongard problems, these fascinating visual puzzles
Okay.
that are designed to test abstraction and analogy-making skills.
Vanguard problems. What are those like?
Imagine two sets of images, each following a different rule or concept.
Okay.
The challenge is to figure out what distinguishes those two sets,
Okay.
to find that underlying sameness that separates them.
So it's like a visual riddle where you have to find the hidden pattern.
Exactly. It requires recognizing patterns, ignoring irrelevant details, and forming abstract concepts on the fly. And as Mitchell points out, even the best AI systems struggle with these tasks.
It makes you wonder if there's something fundamentally different about how humans and AI approach problem solving.
It really
Are we hardwired for abstraction in a way that machines just aren't?
It's a question that continues to fascinate and frustrate AI researchers.
Yeah.
And it's at the heart of the debate about whether true general AI is even achievable.
Oh, so we've covered a lot of ground here.
We have.
We've explored the history of AI, the different approaches to building it, the breakthroughs and the limitations,
Right.
the philosophical questions, and this ongoing quest for common sense and abstraction.
Right. It's a lot to think about.
But I think the question that's on everyone's mind is, where is this all heading?
Yeah.
What does the future hold for AI?
That is the million-dollar question,
Yeah.
and one with no easy answers.
Yeah.
We're at a pivotal moment
Yeah.
with AI rapidly transforming industries, influencing decisions, and even shaping how we perceive ourselves as humans.
It's both exciting and a little unnerving.
Yeah, it is.
I mean, we've all heard those predictions about self-driving cars, the fears of superintelligence taking over, and all the ethical questions surrounding AI.
There's a lot to unpack there.
Yeah, where do we even begin? Well, self-driving cars seem like a good place to start.
Yeah.
I mean, they're already on the roads in some places, and they kind of represent both the potential and the challenges of AI in a very real way.
Definitely. We've all seen those futuristic movies with cars driving themselves effortlessly through busy cities, but the reality is a lot more complicated.
Mitchell talks about these different levels of autonomy, right?
Yeah.
Like level 5 is the holy grail,
Yes.
where the car can handle anything, anywhere, without a human needing to intervene at all.
Exactly.
Yeah.
But achieving level 5 autonomy is a massive leap from where we are now, and one of the biggest hurdles is dealing with what Mitchell calls these long-tail situations.
Long-tail situations, what does that mean?
So think of all those unpredictable, unusual events that can happen on the road.
Okay.
A sudden detour, a tree falling and blocking the road, a child chasing a ball into the street.
Yeah.
Those are edge cases that require human-level common sense and judgment to navigate safely.
And those are the kinds of things that make me nervous about self-driving cars. I mean, it's easy to imagine a computer handling like a well-marked highway, but real-world driving is full of surprises.
And that's the challenge. It's not just about programming the car to follow the rules of the road. It's about giving it the ability to reason, to adapt, to make these split-second decisions in completely novel situations.
So is that even possible? Will we ever have, like, truly self-driving cars that can handle anything?
Well, it's a tough question. Some experts think it's just a matter of time that as AI gets smarter and we gather more data, those edge cases will become less and less of a problem.
But others are more skeptical, right?
Yeah.
Especially given those limits of AI that we've been talking about, like the lack of common sense,
Exactly.
the vulnerability to those adversarial examples.
And that leads to another important question. What level of autonomy should we even be aiming for? Should we be focusing on partial autonomy where humans are still in the loop
Okay.
and can take over when needed?
I mean, that seems like a more realistic approach in the short term, at least until AI catches up to those messy real-world situations.
It might be, but even partial autonomy has its challenges.
How so?
Human drivers aren't exactly known for their perfect attention spans.
That's true.
You know, it's easy to get distracted or complacent when you're relying on a computer to do some of the driving for you.
So there's this tension, right, between the potential of self-driving cars to really make our roads safer and the risks that come with handing over control to a machine that's not quite ready for prime time.
It's a complex issue with no easy answers, and it really raises a lot of questions about how we'll integrate AI into our lives in a safe and responsible way.
Speaking of big questions, what about those anxieties about superintelligence?
Yeah.
This idea that, AI is going to surpass human intelligence and potentially become a threat.
Right.
I mean, it sounds like something out of science fiction,
It does.
but is it something we should be genuinely worried about?
Well, it's a topic that provokes a lot of debate even among AI experts.
Yeah.
Some people believe that superintelligence is an inevitability, given the rapid pace of technological progress.
Right. I've seen headlines about how AI is going to take over the world, how humans will become obsolete.
Yeah.
It's a little unsettling, to say the least.
It's understandable to feel that way, but it's important to remember that those are predictions, not facts.
Right.
And predicting the future of technology is notoriously difficult.
Yeah. Mitchell seems to be cautiously optimistic, though. She acknowledges the potential risks, but also emphasizes the importance of understanding the limits of AI.
Right. She reminds us that a lot of those predictions about superintelligence assume that AI will develop in a way that mirrors human intelligence.
Okay.
But as we've seen, AI still operates very differently from our brains.
Right.
You know, it excels at certain tasks, but it struggles with others that seem effortless to us.
It makes you wonder if those very qualities that we think of as uniquely human,
Yeah.
our emotions, our intuition, our ability to learn from limited data, to connect these seemingly disparate ideas,
Right.
are actually the key ingredients for general intelligence. And maybe those are the things that are going to be most difficult to replicate in machines.
It's a fascinating thought. Maybe the very things that make us human are also what make general intelligence so elusive for AI.
Okay, so after all of this, after this deep dive into AI, what's the main takeaway? What should we as thinking humans be focusing on as AI continues to evolve?
Well, I think the most important message is to approach AI with both a sense of wonder and a healthy dose of skepticism.
Okay.
We should be excited about its potential to improve our lives, to solve complex problems, to help us understand the world in new ways.
Yeah, I mean, we've seen how AI is already changing the way we communicate, the way we work, the way we experience the world, and those changes are only going to accelerate in the coming years.
Exactly. But it's crucial to be aware of the limitations of AI, the potential biases, the possibility of unintended consequences. We need to be thoughtful about how we develop and deploy these technologies to make sure that they're used responsibly and ethically.
So it's not about being afraid of AI or trying to stop its progress. It's about being informed, engaged, and critical thinkers.
Exactly. AI is a tool, and like any tool, it can be used for good or for ill. It's up to us as humans to make sure that AI is used to benefit society and to create a better future for everyone.
I love that AI as a tool, it reminds us that we're still in control, that we have the power to shape the future of this technology.
too.
Maybe that's the most important takeaway of all.
I think you're right. And as AI continues to evolve, we'll need to keep asking those big questions about its role in society, its impact on our lives, and its implications for what it means to be human.
Well, those are some really great questions to ponder, and we hope you'll continue to explore them with us. Thank you so much for joining